Hello, my name is Abe Chavez. I'm a principal consultant here at aPriori, and this is a presentation on how to efficiently cost and analyze assemblies. I thank you for your time, and I hope to be showing you many practical things today. So we're going to do a very quick introduction, just tell you a little bit about myself. And then I'm going to show you how I cost assemblies. Hopefully, there'll be some tips in there. Some things may be new to some of you guys. And then we're going to talk about some reports that we have that are out of the box that will help you how to understand the cost of your assemblies better. Then we're going to talk about two costume reports that we typically deploy for clients. They are actually very widely used now, so they are fairly available. So it shouldn't be too much of an effort to create these reports for you. But I think they will be very useful for you to analyze your assemblies. So let's get going. As I said, my name is Abe Chavez. Most of you in the audience probably already know me. You can see now that that picture is, very old. I am quite much older than that. I started my career back in the mid 80s at GE. I spent 7 or 8 years in engineering, and then I moved into direct procurement as a commodities business team leader. My team basically purchased machine castings, machine forgings, some weldments and things like that, heavy metal type stuff. And then life went on, and the last job that I had actually before I came back to aPriori, I was actually a sales manager for a $20 million boutique machine shop. So I worked a mile on almost everybody's shoes, and hopefully I bring a certain practicality to the things that I show you. So I'm going to start, like I said, by showing you how I cost assemblies. Just to ground everybody, and I know that this is the expert track, so you guys all know that you have to initialize your assembly first, and you get no cost when you first click on the assembly. You have to essentially just click cost, and then the assembly comes alive. At that point, you need to initialize each one of the components inside the assembly, and that's where I hope to show you some practical things as to how I do it graphically. Then I'm going to show you how I copy the assembly settings to the rest of the children. And some of you may already know how to do that. For those of you who don't, I will show you how to do that. And then finally, obviously, you all know, you're on the expert track, so you all know you have to add the details to each one of your parts. If you have paint, you have to add paint to a particular part, heat treatment, things like that. And then the assembly processes, right? Like welds, for example. So we're just going to spend very little time in that. Okay, so let's move right on to the demo. All right, so the first thing we're going to do is we are going to point aPriori to an assembly, and we're going to tell it to open. Again, most people here will already know how to do that. And as I said, you'll have no cost whatsoever. And the very first thing that we do is we just set the volume and the bat size and whatever factory we want, and we just click cost. And what that does is that extracts the parts in the assembly basically, but it doesn't cost them, it just extracts them. And it puts just a little bit of cost. It's just the cost of what we call pick and place, right? Essentially, getting the parts to the cell and putting them in position to be assembled. That's all there is. But now you have to essentially cost the parts inside the assembly. And what I do is I do it graphically. So this allows me to essentially look at the part and see whether it's a bar and tube part or a sheet metal part. And so I move to this assembly details tab here, and I just start holding my control key and hitting parts, right? So that one, I know that's a sheet metal part, so I'm going to hit that one right there and that one right there and this one right here. Uh-oh. that one right there, that one right there, that one right there, that, oops, I want the shaft clamp, and this one right here. And I just start going around basically and just trying to grab all the sheet metal parts that I know are present, right? As I go around the assembly here. And once I selected them, right, I just right click and I say initialize. And then I essentially give the same value of volume that I gave the assembly. So I am going to do that. And then for a material, I pick the most common material. And I understand that some of these parts may be made on one material and some on another. So that you don't have to go change many of them later. Just pick the most common one to start with. So I'm just going to pick I'm just a 1012 steel here. And say okay. And then I just say okay. And there it goes. It's basically going to go through and cost each one of those parts that I selected. So once it's done doing that, what I then do is select the next process. So I'm going to go and select all the bar and tube parts, for example, right? Or I could select all of the parts that are what we call user guided, which is really catalog parts, like this bolts over here, and maybe a couple of the bushings and things like that. All right, looks like we are done. So again, the next thing I would do is I'm not going to pick them all this time, but I am going to just start selecting the bar and tube parts, right? So select that one, and that looks like a tube, and that looks like a bar and tube, and then do exactly the same thing as before. Click initialize, and in this case, I'm going to change this to bar and tube, and set that to the correct way, and set the correct material over here. And I'm gonna pick maybe just a 1020. And say okay. And now it's just gonna cost those two parts basically. All right. And then I can pick another process, which for example is the bolts here. So take those bolts. And I can just initialize. There is bushings and things like that, but I'm just going to initialize this. Actually, I could just open this. I'm just going to cancel here and just show you another way. I can say open. That will initialize all of those parts as well. And I can say manually cost it. And it doesn't matter because this is a catalog part. It doesn't matter what the volume is. And now I can just say, hey, I pay, I don't know, 50 cents for each one of these. And say save. Close it. Okay, and so just pretend that we initialize all of the parts now, right? So now you can see that if I go back to the assembly, now I have a cost for the parts inside the assembly. I still have very little cost for the assembly process itself, but I know that some of these parts are present multiple times inside this assembly. And so the volume and the batch size is probably not correct. So what I want to do is I want to make sure that aPriori spreads that volume and batch size throughout the assembly properly. So I am going to click here where it says scenario and say copy assembly inputs to children. And I am just going to unselect everything so it doesn't worry about all of these things. I just want basically this top 3. And I am going to say okay. And okay, aPriori says I copy them, but some of these parts haven't been initialized yet, so I couldn't copy them. But if you had initialized all the parts, all of them would have been, there would have been no warnings here. If I go back to my assembly details, I will notice that the volume hasn't really changed, right? I mean, there is 2 of these ones, 2 of these parts in the assembly, and I still have an annual volume of 3,000. So what gives, Abe? You know, he didn't actually do what he said he did. Well, in the background he did, but he hasn't recosted with that. So what we want to do is deep cost this assembly. And so we click the cost button here and we say deep cost scenario. This window will come up. And once you have this window open, all you need to do is say cost, and aPriori will spread the proper volume and batch size throughout the assembly. At this point in time, by the way, you could take, you have a chance to change the material on any of these parts that you want to change. So if I know that this part, for example, it's a pedal, so it's a stronger steel, I can come in here and I can say production info, and I'm going to take the time to change the steel to a stronger steel and say okay. Say okay. So now I know the rest are 1012. This one was 1049. And so now I can just say cost, and it's going to give me a warning. And it's going to tell me it's going to want to close the assembly. I said, yes, go ahead. And then it's just going to deep cost the assembly basically. And when it's done, it's going to have the proper volume across all the parts that I had initialized. Okay. Let's see if that's done. So what's going to happen is that the assembly will have closed on the main window. You're going to have to reopen it, and then you're going to see the proper volumes. And then you can add other details to each one of the parts. So if you do have a part that's painted or a part that's heat treated or a part that has special tolerances, those you're going to have to open one by one. But at least this way, you capture most of the parts, you capture them graphically, and you were able to initialize all of the parts that were of a particular process altogether. Okay. All right. This is the way it's going to look, as I said before. So then all you have to do then to complete the cost of the assembly is to add the particular assembly processes. So for example, to these bolts that we costed, we would add, mechanical assembly, and then we would add screw tightening, and we would add welds, whatever welds are present. And after we do that, then then you would have a much higher cost of assembly, because now you would have the cost of the welds and the cost of the mechanical assembly components. So now you have a fully costed assembly. All right. So let's move on. I said I wanted to talk about some out-of-the-box reports that some of you may be aware of and some of you may not be aware of, but they're very helpful in helping you better understand the cost of your assemblies, right? So these reports will help you understand not only the cost, but also the manufacturing of your assembly. So, for example, for engineers, you will know where most of the cost is going so that you can focus your efforts in reducing the cost of whatever is driving it, right? So for example, if you're an engineer and you notice that most of the cost is going into welding, then you can go back and review your assembly and see if, hey, maybe some of this 1/2-inch welds could be 3/8-inch welds, right? And maybe I can do something to reduce the cost of this assembly by following the guidance that aPriori is giving me. Or if you're in sourcing, this will help you understand where the difference between your estimate and the quote that your supplier has given you is, so that you can have a conversation on resolving those differences. Is the difference in the cost of putting the assembly together? Or is it in the cost of the parts? And if so, which part? Or is it the cost of raw materials? And if so, what can you do about it, right? And then the last report we're going to look at is one that will help you track the progress that you're making in either reducing the weight of an assembly, which is useful for engineers, or reducing the cost of the assembly as time goes on. Right. So let's see how that works. So in the beginning, you just look at your aPriori screen and you're going to see right away, as we saw in a couple slides previous, how much of the cost is going into putting the assembly together, the assembly cost, and how much of the cost is going into making the parts, basically, right? But then we really require a little bit more details than that. And this is where some of these reports come from. This first report is actually a spreadsheet report that we have created, and it doesn't come completely out of the box, but it's pre-existing, and it can be yours for just the asking. So just ask your expert services representative to load this report, right? And so you can run it right from aPriori Professional, and it's a pretty nice and complete report, actually. At the top, you're going to see what your inputs are, what my annual volume was, what factory it was, what the batch size and things like that. And then it gives you a summary, both in a graphical way and in a table format. So you can see all of the costs that make up this assembly, right? And right away here, right, you can see that most of the cost of this assembly is going into fabricated material, which is really raw material. And then there is purchase material, which is really the catalog parts that you buy, the bolts, the nuts, the bushings, things like that. But nearly 70% of the cost is going into material. So again, if you're in engineering, you look at that and you say, all right, let me go see if I can reduce the weight of this assembly. My quickest way to reduce the cost is to reduce the weight, right? Is to see if I can consume less material, basically. And if you're a supplier, by the way, that just throws big red flags at you, right? Because the way the materials cost has been going, if I quote this part today, where materials have been coming down over the last couple of months, that is no guarantee that I'm going to still be making money 3 months from now when they might have skyrocketed again. And so, you know, this right away tells you, you better make sure that there is an escalation clause and that is iron tight, right? Because you have a lot of risk in the fact that most of the cost of this assembly is going in material. All right, so let me show you where that report lives and how you can run it. Okay, so let's take a look at this assembly that we have open here. I am going to simply go into reports, click on spreadsheet reports, and yours is not going to be called Abe, it's just going to be called enhanced summary report here, but I'm just going to put it somewhere. I'm going to say yes, and just put it in documents here. And this report is going to come up. We can make it so that we can read it here. and how, again, you can see all of the information at the top, and then you can see the summary of the cost, and then you can see cost about every part in the assembly. You can see what process was made to use it, whether it's bar and tube, sheet metal. Then you can see the type of material, the cost per kilogram of material that was assumed, the total material cost, and then obviously all the different details, labor, overhead, and things like that. And then the total, obviously, the total cost of the part here, and then the total of the assembly at the end. And if we click in any of these links here, it will bring us to a graphic of the part so you can actually see the part. So it's a very, very nice report that has very complete information for you to have a discussion with a supplier, a customer, or an engineering, just to look at the details of where your cost is going. So next, we're going to look at a couple of reports that come out of the box on our AP Analytics product. So these reports are meant to give you similar information and then some from that spreadsheet report. So the first one it's called assembly cost. And I am going to look at that hitch, basically. And I am going to say, okay. And you can see if I expand this a little, you can see, general information similar to what that spreadsheet report was showing you, right? All the inputs into the cost of that assembly, the material, labor, overhead, any tooling cost. There is a plastic part in here, so there was some tooling. And this one actually gives you some cycle time information. So this is a summary of all of the different cycle times that were consumed to make all the parts and the assembly of this assembly. And then you can see here that I have more pages. And so if I go review what's on the other pages, then you get information about each one of the parts in the assembly. So this assembly here, this part here, for example, is a sheet metal part. You can see the process that was used to make it. It requires a laser cutter, and then it must have a tight tolerance on one of the holes because it required actually that a 3-axis mill is used. And so you can see the routing that it was used. You can see the overall cycle time for each one of the steps. You can see how much weight it consumed, what the cost per kilo is. So very, very much details on the cost of each part, basically. The other report that is available to you is called Assembly Details. And I'm going to pick the same hitch here. And this will give you basically a general summary of the cost of each part, just very general information. The part number, what material was made out of, what the process is, general cycle time, and things like that. But then if you click on each part, then you can get, let's just click this one here. You can get more details about each part. So a summary of the part, and then on the second page, a little more details about the routing of the part, and the labor and overhead rates that were assumed to make it. So a lot more detail on the cost of each part than the prior report showed. These are available to you either for the asking or right out of the box. The next report is an ad hoc report that, although it's not available to you out of the box, it can be deployed very simply. Just if you have expert services, we can create it for you very quickly. And this is a cost tracking report. So this report allows you to track the cost and the weight of an assembly throughout certain periods of time, right? So the black bar here is your cost, and the scale is on your left. And the red bars are your weight, and your scale is on the right. I can look at both of them combined, or I can look at them separately, just the cost or just the weight of the part. The time periods that I have here are daily, but that's just because it's what I had to create a data set, and then so I had to like cost it and then make a change and cost every day so I could get a time sequence. But you would be able to simply export this assembly from aPriori into the reporting system and then tell it to export every week, and then forget about it. Then every time you need to run a report, you could run this and it would capture all of the changes, whether you're in engineering or in sourcing, right? And you can change the time period, right? It doesn't have to be daily. I can set that to, yearly, quarterly, monthly, hourly. All right, so we have a lot of choices there. And then the system wants to know, okay, let's say you want to look at it monthly, right? January, February, March, April, May. aPriori wants to know, what do you want to see? Do you want to see the minimum, the maximum, the mode, the median? I simply chose the average here, right? But you could tell it to show me the minimum, right? And that's what you want to see. So same thing for both the cost and the weight, obviously. You can also drill into the parts of this assembly. So you can look at it at the assembly level and see how this is tracking. And then I can look at it at the part level. So if you're in engineering, for example, and you can see in the beginning, you can see what my two big cost drivers were over here, right? These two parts were the biggest cost drivers. So if I'm working on redesigning this assembly to make it cost less, I don't worry about this parts down here. I can make very little difference. I'm going to worry about this too. And that's what this engineer did. Unfortunately, what happened is by reducing the cost, that person increased the weight. And so now we're going to have to come back later and address that. And then he or she went out and see what kind of difference they can make on the small parts. And you can see that it was some small difference here. And then they tackled the two remaining highly cost parts to see what they could do about cost and weight. And as you can see, some difference was made on this part regarding both cost and weight. And that's why when you look at the assembly, you can see the cost is going to continuously come down, but the weight went up, then it went down a little, and then it went down a little more. But the way that you can drill into the parts gives you proper guidance for what is it that you need to attack, right? Whether you're in engineering or in sourcing, if you are discussing this with a supplier and you know that this is the two highest cost parts, then you can talk to the supplier about what you can do about reducing the cost of those parts, right? And don't worry about the little ones because those are not going to gain you anything. Moving on to some of the more advanced reports. There is a way to use aPriori to compare like assemblies to see if they are worth investigating farther from a cost point of view. And I'm going to use a part to explain the principle because it's easier to understand that way. Okay, so bear with me for the moment. let's say that you're buying this casting at the top. And I chose a casting because all of us that have been in sourcing and have purchased casting have been conditioned to believe that the cost of the casting goes with the weight of the casting. So it's directly proportional. So if this casting is 5 kilograms and it's costing me $15.50, if I ask for a quote from the supplier for another casting of the same material, right? And that weighs 10 kilograms, and the supplier comes back with $31, I'm perfectly happy with it because I'm conditioned to think it's a direct proportional relationship between cost and weight. But now, because aPriori has both manufacturing and cost data, now you have a little more information. And now you know that the casting at the top is made on the same machine or the same size machine that the casting at the bottom. And the casting at the bottom really only takes 2 more minutes to make. So yes, it has more material cost and more manufacturing cost, but they're not both proportional in the same way. And so now I can do some math and take the $15.50, which is the price from the supplier, subtract the cost of material, $5, divide by the time that it took to manufacture, and I can see that I'm paying $2.1 a minute for manufacturing of this casting. And I can do the same for the one at the bottom, take 31 minus 10, divide by the 7 minutes. And now I can see I'm paying 3 minutes for manufacturing of this casting. And it's actually made in a pretty similar way. So why am I paying 1.5 times that, right? And we have used this many, many times to uncover a lot of potential savings for customers out there. Right, so this is basically a real set of data from a customer. The supplier confirmed that all of these castings were made on the same machine, essentially, and we plotted basically the quarter cost, which is the price, minus the material times margin, because they charge you profit on the material, and then we divide by the cycle time. And we can see spikes, right? I'm not worried about small differences in ratio because, hey, the bigger casting will take more to clean up, right? Take more time to clean up, things like that. It's a little harder to handle. So yes, there will be a little more cost with the bigger casting. So I'm not worried about small spikes, but I am worried about big spikes, right? 1.5 times, 2 times, things like that. Well, we can do the same with assemblies. And assemblies is a little bit more complicated. And the reason that it's a little more complicated is because not only you have the difference in the way that you are putting the assembly together, so we do encourage you to narrow the assemblies that are compared on the same chart to the same process, meaning if an assembly is mostly welded via manual MIG, for example, even though it might have a couple parts that are bolted, as long as it is a dominant process to assemble, then pick that process, right? So narrow the assemblies down to the main process: manual MIG, robotic MIG, manual TIG, mechanical assembly. And so that you are comparing apples to apples. The second thing that you have to worry about is what are the parts inside the assembly. So it is important that the parts are made as nearly the same way as possible. And so if you are going to use this method for assemblies, you need to make sure that, hey, this is an assembly of mostly sheet metal parts that are sheet, or mostly plate parts, meaning parts that are, 3/8 of an inch or more, right? For the most part, right? Exceptions are okay, but for the most part. assemblies that are made out of machine parts, like machine castings and machine forgings put together, bolted together, and things like that. Those would go together, but you couldn't combine them with sheet metal assembled parts. And so once you have segregated the assemblies that way, then you can use a similar methodology and run this report, and then look for bigger spikes. So while this might be a 2-to-1 ratio here, I would only call this one a potential outlier, and not a clear outlier, because there's going to be many differences in the parts are going to naturally cause a difference in this ratio. And so you can't just look for small differences, right? It's not just the small differences that you want to rule out. You're going to rule out some pretty big differences. So I typically say, if you're looking for assemblies, the spike needs to be bigger than a 2-to-1 ratio, basically, for assemblies. There is one last thing that I like to discuss, and that is the question of, should this even be an assembly? I mean, how many times have you looked at an assembly that you are making or that you're buying and saying to yourself, would this be cheaper as a casting? And that is especially true because a casting typically has a better utilization than sheet metal parts. You can get in the 80%, mid 80s, high 80% utilization for castings, right? And so you are going to be using a lot less material and carry a lot less risk of being affected when this, yo-yo of material prices happens, right? The other thing that you would mitigate is the talent shortages that we are seeing. There is a shortage of certified welders. And so sometimes you're going to get your parts late simply because your supplier didn't have the skilled labor necessary to make all the production that they needed. Maybe somebody got sick, right? And so by going to a casting, you eliminate that risk. So it is beneficial sometimes to go to a casting, but the question is when. And so we got you covered there, okay? So I'm going to show you a couple of reports that you can run that will indicate to you which parts are candidates to be at least considered to be a casting, so that you don't have to look at all the assemblies and say, okay, I'm going to study this one, I'm going to study this one, right? This analysis will tell you these are the ones you should look at. To do that, we look at 2 reports. And again, they're going to be in the ad hoc side, and we can create those for you. We have done this for many other customers. So if you have expert services, they can create this for you. So the first one that we look at is this one called like capacity consumption. And the reason we look at that one is because we want to know how much MIG welding we are using, right? Whether it's robotic or manual here. And so this is a collection of assemblies. And so the first thing I want to look at is the consumption of skilled labor. And so you can see how, this basically this 3 assemblies here, especially the hitch that we were looking at, are consuming a significant amount of MIG welding. The hitch, unfortunately, has moving parts. And if you cast it, those parts ain't going anywhere. They're not moving. So that one is eliminated just from the point of view that you can't cast it. But the other 2 are definite candidates. All right. So that's one view. The next view is going to give us some better guidance. And so what we are going to look at is this near net shape report. And what this report is showing you is the effective utilization of the assembly. So this is the average utilization of the parts. It takes all of the gross mass of every part and divides it by actually all of the finished mass of the assembly and divides it by the gross mass of each part, all summed up together, obviously. And so you get an effective utilization. And this basically tells you how much you have to gain if this was a casting, right? So I said that a casting will probably get you at least in the mid 80s, somewhere around there. So I can see that for this assembly, I could gain 20 points, right? For this assembly, I could gain 20 points. So what that means is that if I'm spending $230,000 a year in material on this assembly, if I can get 20% out of that, right there is $46,000. And the cost of putting that together over a year is nearly $13,000. So, and that will go away because I don't have to put it together anymore. So my opportunity here is, probably, better than $50,000 that could probably pay for the tooling and then some. So now I know that this assembly and probably this assembly as well are good candidates for being considered to be a casting. And so now, if I'm in engineering, I know that it's worth it for me to look at this farther. And if you're in sourcing, you know that it's worth it for you to talk to both the supplier and your engineering team and say, hey, should we look? I keep getting this part late because it has a ton of welding and there is a shortage of welders out there. And it looks to me, based on the analysis I've done, that this could be a casting. Can we consider it, right? And now you have data to back that up, and it won't be a waste of the engineer's time, right? So if we look at those parts, so this is your sub-assembly. And so here you can see the entire cost of the assembly, the cost of putting it together, the cost of the subcomponents. And so what you can do with aPriori is if you get what we call a shrink wrap model, so you take this assembly model in your CAD system and you tell your CAD system to save it as a part, and it has to be saved as a solid, not just a surface model. And then you tell aPriori to cause that shrink wrapped assembly model, essentially, so because it's now a part, what aPriori will do is it will give you a pretty good estimate of the cost of that casting. Now, it's not exact, right, because this is not a casting model. You may end up actually just doing the sub-assembly at the top here and then just welding these two parts together in the end, right? But at least you get an idea of what the potential savings might be between the two parts, right? So this is 109, basically 110, and then this one is 180. So it's $70 per part, even if it's only 50, because after you make your casting model, this difference will probably drop. So even if it's only 50, right? It's $50 and 1,500 parts. So basically, you're talking about $75,000, right? So that is probably worth your time to make a casting model. And so that's what we aim to do, is to show you when is it worth your time to investigate farther to be able to realize some potential savings, some significant potential savings. So I hope that I had shown you some things that you didn't know before. This is the way that I approach assemblies. This is the way that I analyze assemblies for my customers, whether I'm looking at it from a supplier or a sourcing person or an engineering person. And so if you have any questions, please don't hesitate to write me an email. I am always here to help, and I'm always happy to help. Thank you very much, and have a great rest of your day.